Hello, my dear young minds. Welcome back. How are you, students? I hope that all are fine. Students, previously we discussed motion chapter and we studied different types of motion, and also we discussed some of the physical quantities. So, what are derived quantities? What are fundamental quantities? And also we studied what are scalars and also vectors, and also we discussed some of the physical quantities like distance traveled by a body, displacement, speed, velocity of a body, acceleration, and also retardation. And based on these physical quantities we also solved some numericals, and we discussed first kinematic equation and also second kinematic equation. Students, today we are going to know about two derivations. Those are second kinematic equation and also third kinematic equation. Students, second kinematic equation is S is equal to ut plus of 8 square. One second, students, I am saying the second kinematic equation S is equal to ut plus of 8 square. See, students, how we will derive the second kinematic equation. It is very easy. If you observe clearly and if you try to understand, you can easily derive the second kinematic equation. Students, S is equal to ut plus of 8 square. So here this equation gives the distance traveled by a body in time t. So it gives the relationship distance traveled by a body in time t. So S is equal to ut plus of 8 square. Students, let us consider that a body is traveling, or a body is having uniform acceleration a. Uniform acceleration a, and initial velocity of the body is u, and final velocity of the body is v, and the distance traveled by a body is s, and the time taken is t. So what we are considering? Let us consider a body has uniform acceleration a meter by second square, and the initial velocity of the body u meter by second, and the final velocity of the body is v meter by second, and time taken t seconds, and the distance traveled by a body is s. So s in meters. So s is measured in meters, distance traveled by a body, right? So how we will derive this second kinematic equation? S is equal to ut plus of 8 square. So students, here I am writing, so initial velocity, final velocity, time taken, distance traveled, uniform acceleration. Please observe clearly. See students, what we said, let us consider a body is having uniform acceleration. So uniform acceleration a. So uniform acceleration is a. It is the unit of SI unit of acceleration is meter by second square. And students, initial velocity u meter by second. And students, final velocity v meter by second. Time taken t seconds. Time t seconds. Distance traveled by a body is yes meters. Yes meters. Students, velocity is always changing. But it changes at a uniform rate. So that average velocity is equal to arithmetic mean of initial velocity and final velocity. Please remember students, average velocity equal to arithmetic mean of initial velocity and final velocity. That I am writing here. So students, average velocity. Average velocity. Average velocity V is equal to initial velocity plus final velocity by 2. So here for our convenient I am writing here VAVG. VAVG means average velocity. So average velocity is equal to initial velocity plus final velocity by 2. Students, remember, if we know this formula, we can easily derive the second kinematic equation. So what is the formula for average velocity? Average velocity V is equal to initial velocity plus final velocity by 2. Observe clearly, students. See students, we know that velocity formula, velocity is equal to displacement by time taken. V is equal to formula S by T. Students, remember, what is the formula for velocity? V is equal to S by T. S means distance, displacement traveled by a body or distance traveled by a body and a specific direction by time taken. So V is equal to S by T. So here V average velocity. So that I am writing here AVG. Average velocity. So average velocity is equal to S by T. So average velocity means we know that initial velocity plus final velocity by 2. So now I am writing here, instead of average velocity, I am writing U plus V, arithmetic mean of initial velocity plus final velocity. See students, observe, U plus V by 2 is equal to S by T. Students, U plus V by 2 is equal to S by T. Observe clearly, identify. So this kinematic equation, second kinematic equation derivation is very easy. First, suppose consider a body has a uniform acceleration, initial velocity, final velocity, time taken, distance traveled by a body. So velocity is always changing at a uniform rate. So that we taken average velocity is equal to arithmetic mean of initial velocity plus final velocity by 2. So here we know that velocity is equal to formula distance traveled by a body by time taken. So V average is equal to S by T. So instead of this average velocity, just I have written U plus V by 2 is equal to S by T. Don't get any confused. So very easy. So U plus V by 2 is equal to S by T. Students, observe. Now one more observation. Students, remember, here this U is initial velocity and V is final velocity. Students, according to first kinematic equation, we have a final velocity formula. So final velocity V is equal to U plus AT. Remember students, according to first kinematic equation, final velocity of the body V is equal to U plus AT. So final velocity V is equal to U plus AT. Now substitute this final velocity here, because here this is initial velocity and this is final velocity. So now final velocity we know according to first kinematic equation, V is equal to U plus AT. Remember students. So now what I am doing, substituting this final velocity formula here. So U plus V, instead of V what we have to write? U plus AT. Remember students. So I am substituting this final velocity in this equation. First equation for example. So if it is second equation, so the value of final velocity I am substituting in first equation. So which one? Final velocity value. So substituting final velocity value in first equation, you please write down U plus, instead of V what I am writing? U plus AT. Just for this, instead of this V what I have written? U plus AT by 2 is equal to S by T. Right students, see U plus U, U plus U, U plus U. So 2U plus AT by 2 is equal to S by T. Now students, cross multiplication. So 2 into S is equal to 2U plus AT into T. I am writing. So 2U plus AT into T is equal to 2 into S. Cross multiplication students. 2 into S is equal to 2U plus AT into T. So T into 2U, 2UT plus T into AT, AT square by 2. Already 2 we send. So is equal to 2S. 2S. So 2UT plus AT square is equal to 2S. Students observe. Right? Now S is equal to send this 2 here. 2UT plus AT square by 2 is equal to S. And again I am rearranging this term. See, 2UT by 2 plus AT square by 2 is equal to S. Students observe, if you write 2UT plus AT square by 2, or we can also write as 2UT by 2 plus AT square by 2, because both are same only. Just I rearranged the equation, right? See students, here 2 cancel, and what we got, UT plus AT square by 2 is equal to S. Or we can write this, S is equal to UT, just here AT square by 2, just I am writing as 1 by 2 into AT square. Students observe here, just I written 1 by 2, just 2 I have written as 1 by 2 into AT square. So S is equal to what we got, UT plus of AT square. What we got finally? So distance traveled by a body in time t is equal to UT plus of AT square. This is called second kinematic equation. What we call second kinematic equation, students. Remember, once again I am explaining, students. First we have to consider that a body has a uniform acceleration. So A meter by second square, and the initial velocity of the body is U meter by second, final velocity V meter by second, and the time taken is T seconds, and the distance traveled by a body in a specific direction is S. Students, velocity always changing at a uniform rate, so that I have taken average velocity. Average velocity is equal to arithmetic mean of initial velocity plus final velocity by 2. So here I have written average velocity formula, V is equal to U plus V by 2. So but we know that average velocity is equal to displacement by time taken. That means distance traveled by a body in specific direction by time taken. So U plus V by 2 is equal to S by 2. So according to first kinematic equation, we have taken the help of first kinematic equation. First kinematic equation gives the final velocity. So final velocity is equal to U plus AT. So that I have substituted here. Instead of V, I have written final velocity formula. So U plus AT by 2 is equal to S by T. So here U plus U, 2U plus AT by 2 is equal to S by T. So when we are cross multiplying, so we got 2UT plus AT square is equal to 2S. But we want distance traveled by a body. So S is equal to 2UT plus AT square by 2. So rearranging these terms, we got S is equal to UT plus of AT square. So this is, students, second kinematic equation. Second kinematic equation gives the distance traveled by a body in time t. Distance traveled by a body in time t. And we will learn third kinematic equation. It is also very easy, students. Third kinematic equation derivation is also very easy. So first please try to once observe the second kinematic equation. Please once you observe. And when we are discussing anywhere, if you have doubt, you please ask me. I will again give the explanation. Students, once you please identify, observe, and try to note down this second kinematic equation.